Is it a minimum or is it a maximum? Minimum because the leading coefficient, which is right here in front of the parenthesis, which is 1, is positive. So A equals 1 positive, the quadratic function must have a minimum. Can anyone give us the vertex? Very good, excellent. 4, comma, negative 4. Any questions? Do the x-intercepts exist?
Yes.
How do I know that? Because it has a minimum, and because the minimum value is how much? Negative 4. Can you already picture the graph and give me the range? If I were to ask you, right now, don't do anything, give me the range. What will be the range? Exactly, negative 4 to infinity. So the x-intercepts indeed exist. So we have to find them. How do we find the x-intercepts? Exactly. I said y equals to 0. That's where we are right now. We are setting y equal to 0, and we are solving the equation for x. Which method would you use to solve? We have 4. Which of those 4 methods is the best here in this case? Taking the square root. Very good. So this is x minus 4 squared minus 4 equals 0, which is x minus 4 squared equals 4. And then we take the square root. You cannot take the square root before you separate 4 from the rest, because we cannot take the square root of a sum or a difference. So we are in step 3 right now. We're finding the x-intercepts. Don't forget plus or minus. This is a quadratic equation. So we have x minus 4 equals plus or minus 2. And we have to put the 4, when I move it, not between plus or minus and 2, but between the equal symbol and plus or minus. So x equals 4 plus or minus 2. So then there are 2 options for x. What are the options for x? Very good. X equals 6 and x equals 2. So what are the ordered pairs that we will plot as x-intercepts? Sorry. 6, 0 and 2, 0. Good. Now we are in step 4. The y-intercept. How do I determine the y-intercept? Yes. So I have to find f of 0. So let's do this together. 0 minus 4. Negative 4 squared. 16 minus 4. That's it. So what is the ordered pair that represents the y-intercept? 0, 12. The last 2, 5 and 6, I can even add them in here. They're just words. The axis of symmetry has to be a vertical line, x equals 4. Have to write x equals 4. What is the maximum or the minimum? We already established is not a maximum but a minimum. So what is the minimum value of this function? Right, is negative 4, or y equals negative 4. We have all the information we need in order to graph this function. Ready? The axis of symmetry. Minimum value is negative 4. Minimum value, there is no max. There is a minimum. It's either max or minimum, but you cannot have both. So it's minimum. The minimum value is negative 4. So let's graph this function. The vertex is at 4, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. So here's the vertex. Here's the axis of symmetry, x equals 4. I plot the x-intercepts at 6 and 2, 2, 6. Remember, these two have to be symmetric. They're not in my case. As you see, this is bigger unit than this. So careful. Okay, so, and 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. Far from being perfect, but it kind of looks symmetric. So f of x equals x minus 4, everything squared minus 4. Any questions on graphing? Any questions on graphing? Okay, let's look at a couple of word problems now. 54. The function h of t equals negative 16t squared plus 120t plus 300 gives the height in feet of a projectile fired from the top of a building after t seconds. So here's the building, and we fire the projectile up in the air. It will definitely do this. It will reach a maximum, and eventually will definitely hit the ground. Okay? First question. When will the object reach a height of 350 feet? Obviously, when t is 0, this is 300. So this is the height of 300 feet. So we're asked to determine when will the projectile reach a height of 350. So I'm going to say this is the height of 350 feet. If it's not the maximum, because this point could be here. So I don't know, we'll see in a moment if that's true or not. But if it's not the maximum, the projectile will do this. It will cross this line of 350 feet, 350, on its way up, and then again on its way down. So if this is point 1 and this is point 2, I'm going to call this 3 and I'm going to call this 4, then I should get a different time between 1 and 2, and definitely a different time from 1 and 4, if that's the scenario. Okay, but let's see, this is our idea of what's happening here. But how do I proceed? So we're asked to find when will the object reach a height of 350 feet. I have to come up with something and that I can solve, because otherwise I will not be able to determine when. So what would you recommend we write? Exactly, the distance is 350. 350 equals negative 16t squared plus 120t plus 300. Very good. The height, the function is giving us the height at any moment in time. So we are trying to find when the projectile crosses the line or the height of 350. So let's think about this equation for a minute. Can anyone dictate a step? First thing we should do? I will move everything to the other side. I refuse to solve a quadratic equation with a negative leading coefficient. So I'm going to write 16t squared minus 120t and plus 50 equals 0. Then I noticed something. Always remember, factor, simplify, factor, simplify. It's not factorable. But I can simplify the equation. What will I divide both sides by to simplify it? Smaller, exactly. Smaller the numbers, the better. So then I have 8t squared minus 60t plus 25 equals 0. And then, what will I use? Right. So let's work on this for a second. Let's see what we get. I recommend write it first and then put it in the graphing calculator. So how will you write it? 60 plus or minus the square root of 60 squared minus 4 times 8 times 25 for AC divided by 16. Please put in the graphing calculator and determine solutions. Don't forget this. Again, the newer calculators may perform. Yes, okay. Nothing y equals. Just normal. Left parenthesis, 60 plus the square root of 60 squared. Perfect. Minus 4 times 8 times 25. Perfect. Close the parenthesis, close outside, and divide by 60. Perfect. And now do a second entry, and go exactly. And then you'll have both solutions in front of you. So left parenthesis, 60 plus the square root of 60 squared plus, not plus, I'm sorry, minus 4 times 32 times 25, close, outside, close, and divide by was 60. Okay, and then when I copy and I replace, it's easier for you, I think, with the calculator than with the software. Okay, minus. Okay, so we got T1, which is 0.44 seconds, and T2, which is 7.06 seconds. Which means between this point and this point, the projectile needs 0.44 seconds, but between 0.1 and 0.4, the projectile needs 7.06 seconds. Between 1 and 4, 7.06 seconds. Between 1 and 2, 0.44 seconds. Did we get the same thing? Everything okay? Yes? Okay. Now, this is not in the book, but I would like to add a question here. Find the maximum height. So let's find the maximum height. 1 minute. Can anyone tell us what to do, how to find the maximum height? We have to find the vertex. That's all we need. Very good. And which of the two coordinates of the vertex will give us the maximum height? I know it's a silly question, but I need to ask. The y-coordinate will give us the maximum height. The x-coordinate will tell us how long it needs to get to the maximum. It's the x-coordinate. Very good. Any questions? So how do I find the x-coordinate of the vertex? Yes, it goes together with a quadratic formula. Negative. B, be very careful. Always keep everything in descending order because you may incorrectly identify B. So a x squared plus bx plus c. So this is b. So 120 divided by 2 times a, negative 32. Remember, this is time. It has to be positive. So I will divide because I need it later. So 120 divided by 32. 120 divided by 32. And I got 3.75 seconds. So what is 3.75? It's the time needed for the projectile to go from point 1 to point 3. 3.75 seconds, from 1 to 3, where it reaches its maximum height. Good. So now how do I find the maximum height? Plug it in the function. So I go back. So I have h of 3.75. And going back to y equals. This was not our function, right? Let's see. Negative 16x squared. So this is plus 120. I'm going to insert 120 and then delete this. And then plus 300. Good. So I have second and table, and I'm plugging in 3.75. So the maximum is 525 feet. So 3.75, 525 feet. Perfect. Any questions? Any questions? Okay, next question. We're asked to solve x cubed equals 27. How many solutions will we come up with? This is problem 21. 3 solutions. Okay, so let's work on this for 1 minute. The solutions can be real, imaginary, doesn't matter. I have to present 3 solutions. So let's work on this for a minute. Let me know if you need help, please. Can anyone get us started? Just the idea. What do we want to do first? I will only get 1 solution. Because there is no plus or minus when you take the cube root. I will only get the real solution. It's a very good method. In case I'm asked, just find the real solution, yes. There is only 1 number that I take to the 3rd power to get 27. There is no other number. But I will not get the imaginary solutions. Very good point. So I'm forced to set it equal to 0 and factor it. It's a binomial. I have 4 special products for binomial. However, only 2 for difference and 2 for the sum. So what do you think this is? Difference of cubes. Once you say difference of cubes, then we will have to find a binomial and a trinomial. It is safe to start with a sequence of signs, so we don't mess up the signs. So if this is the difference, what do we have in the binomial? Minus. What do we have in the middle of the trinomial? Plus. The last one, we don't even discuss it. It's always positive. Perfect. Now let's identify what we cube to get x cubed. What do we cube to get 27? 3. So now remember, first one squared, last one squared, and in the middle the product of the 2. So what do we have in the trinomial, sorry? Yes. We have to multiply. 3x and plus 9. I already have one solution, which is 3. Very good. But now I have to solve the other equation, which is this. Please keep this in mind if you can somewhere. Every time you factor a difference or a sum of cubes degree 3, this will only have imaginary solutions. So when we have a factored form coming from a difference or a sum of cubes degree 3, because if it's degree 6, this could be factorable. But if it's coming from degree 3, this portion, this trinomial, will only have imaginary solutions, always. You can't even try, don't even try to factor that. It's not factorable. Good. So I got one solution from here, but now I have to get 2 solutions from here. How do I do that? Which method will I apply? The only one that works here. I shouldn't say the only one. I could complete the square, but yes. So then we have x equals -3 plus or minus the square root of 9 minus 4 times a times c over 2a. Don't look at this, just write it yourselves and then look. I'm sorry, I should have waited. I'm sorry, I apologize. Because I want to say something about the next step. Is this okay? So negative b plus or minus b squared minus 4a times c, but a is 1. Here's what I recommend you do next. It's up to you, of course, there are so many different ways. But this is what I would like to do. Instead of multiplying this and then subtracting 9, or 9 minus this, and then having to deal with -27, I would rather notice that these 2 terms have 9 in common. 9 times 1 is 9. 9 times 4 is 49. 4 times 9, right? 9 times 4, negative 36. So then I write this, the square root of 9. I'm allowed to split it because it's a product. So it's 3, and then this is the square root of -3. Of course, it doesn't matter. You can still write 9 minus 36, which is -27, and you still get the same thing. But then you'll have to look at -27 and say, oh, okay, this is this, and this, and this, which is fine. You're going to get the same answer. So finally, I will have to write the I here. So x equals -3 plus or minus 3i, the square root of 3 divided by 2. And we found 3 solutions as expected from the very beginning. So we had x equals 3, which was the only real solution. And we had these 2 imaginary solutions, -3 plus 3i, the square root of 3, and -3 minus 3i, the square root of 3 over 2. Any questions? Any questions? Let's look at 55 on 709. Find 2 numbers. I'm taking notes when I read. 2 numbers whose product is as large as possible, so maximum product, given that their sum is 420. So I'm asked to find 2 numbers with a possible, with a maximum possible product whose sum is 420. So do I have the numbers? Well, the answer is no. No, I don't have the numbers. I cannot use specific numbers. I have to give them names. How would you like to call them? Very good. So the numbers are x and y. Now, can anyone give us the sum of these numbers equals 420? Of course. So I use this for now. I show that their sum, the sum of these 2 numbers that I'm looking for, that I don't have, is 420. Yes?
You were 40.
Oh. No excuse. Thank you. No, I didn't try to see if I could get away with it. I don't know. Okay, so this is done and over with. Now I'm thinking of writing their product, right? So their product, I know the sum is 420, and their product is, I don't use this. How do I write the product of these numbers? Right. Okay, so I took care of this somehow. I have the sum taken care of. Now I'm having difficulties with this. Not difficulties, but that's my next step. Okay, which function has a maximum from what we studied so far? Only one function has a maximum, right? That we discussed in this course. And that function is called quadratic. But I don't have a quadratic function yet. So I'm asked to find the maximum of the product. So the product has to change into a quadratic function somehow, because otherwise I don't know how to find the maximum of this. So this is not a quadratic function yet, but I have to use the information I'm given. I have to solve this, either for x or for y, you decide, it doesn't matter. And then I have to replace that variable here. And then it will change into a quadratic function. Right now it's not a quadratic function. So which variable would you like to solve this equation for? Okay, if we solve for x, then what do we get? Very good, negative y plus 420. Now I'm going to replace this x by this piece that I just determined, because x or negative y plus 420 is the same thing. And now this is a function that is quadratic, but I don't have it yet. So can anyone dictate? Plus 420, so for everyone to see, times y. And yes, negative y squared plus 420y. Remember, it's important to keep everything in descending order for so many reasons. The vertex, factoring, everything depends on descending order. Good. Okay, so now I'm going back to my notes to make sure that I have everything in order. I have two numbers. Here they are. I have their product. It's a quadratic function. I use the sum as being 420. So I developed a function. I created a function that is quadratic. Does it have a maximum? Because I'm asked to find the maximum product. Does this function have a maximum? Good. How do I find the maximum? Right. So the vertex. How do I find the x-coordinate? Because I can't find the maximum product before I find the x-coordinate of the vertex. Very good. Negative e over 2a minus b. Remember descending order. B is good over 2 times a. So the answer is 210. So when y is 210, we found one number, which is 210. If y is 210, how much is x? Exactly. And remember, this is the product. This is the product, and this comes from here. You have two options. You either take y and plug it in here to find the y-coordinate, or because this equals this, and you have now x and y, multiply these two and put it here. It doesn't matter which method you use. Because this is the same with this. I have x, I have y now. I multiply them and put the number. So how much is 210 squared? 21 squared is 441. So 44100. I have to write the conclusion of the problem, or the solution if you want. Here's how I write it. The maximum product of two numbers whose sum is 420 is the maximum product $44,100. The numbers are 210 and 210 respectively. So the maximum product of two numbers whose sum is 420 is 44,100. And the numbers are 210 and 210 respectively. Okay. Would you like more graphing? Would you like more word problems? Would you like completing the square? Would you like quadratic in form? What should we look at next? Another word problem? Yes? Perfect. Page 710. Problem 22. They are pretty similar, all of them. 710. A stone is thrown upward from a bridge. The stone's height in feet, s of t, above the water, t seconds after the stone is thrown, is a function given by the equation s of t, negative 16t squared, plus 32t, plus 256. Find the maximum height of the stone. Find the maximum height of the stone. Let's work on this for 1 minute. What are we going to find? The vertex. So negative b over 2a. Negative. Careful, this has to be in descending order. 32 over 2 times a. So the time needed for the stone to reach its maximum height is 1 second. That's the time. But how do I know what is the maximum height reached by the stone? I have to plug it in. So it's S of 1. Very good. So S of 1, negative 16 plus 32 plus 256. So negative 16 plus 32 is 16, so I only have to add 16 to 256. So S of 1 is, and what do I have? I have 272 feet. That's the maximum height. Part B. Find the time it takes the stone to hit the water. Oh, sorry, I wrote 256 instead of 272. Find the time the stone needs to hit the water. The height is from the water up. So it's like the water is the ground level in this problem. So how do I find the time needed for the stone to hit the water? S of t equals 0. Good. So that's negative 16t squared plus 32t plus 256 equals 0. Try to simplify it as much as possible. If it's not factorable, then use the quadratic formula. If it's factorable, then factor it. Are you giving me a few more minutes today? Yes? Okay, thank you. Should I look for another word problem, or should I look for graphing, or in the meantime? Graphing? Yes? Perfect. And always simplify the equation as much as you can. So now I would like to check whether 256 is divisible by 16. Is it? Okay, so then we will divide both sides by negative 16. So t squared minus 2t minus 16 equals 0. It's much easier to work with. Still not factorable, but that's okay. So then t equals, I'll wait for you to write it. Yes? Minus 4 times 1 times negative 16. So that's why I'm going to change this into positive, because there are two negatives in there. So here I'm not going to do anything like factoring or anything like that. I'm just going to use the graphing calculator and get the solutions. So parentheses around the numerator. So 2 plus the square root in parentheses 4 plus 64. Close parenthesis and divide by 2. The other one with minus. Unacceptable, because we are talking about time. So the only solution is 5.12. Good. So let's look at graphing 49 and graphing 52, and then we can stop. Unless you have questions for me. Would you like to go back to chapter 6 in any way, shape, or form? This was all about factoring. Okay, so we can work on these two, and then we can stop. So here's 49. We're asked to graph. Both of them are graphing. X squared plus 10x plus 25. And the other one is f of x negative 5x squared plus 5. Same steps from before. We start with the shape. What is the shape for this one? Yes, minimum, because the leading coefficient is 1, so the quadratic function has a minimum. 2, the vertex. So let's find the vertex. So negative b over 2a, negative over 2, so it's negative 5. Very good. How do I find the y-coordinate of the minimum? Plug it in. So f of negative 5. Negative 5 squared is 25 minus 50 plus 25, and I get 0. What does that mean? Let's think for a moment. The function opens upward, and the minimum value is 0. So will I find other x-intercepts? No. This is the x-intercept, right? Which means the discriminant is 0. Exactly. We have only one solution, and that is also the vertex. Very good. So then a vertex is negative 5, 0, and the x-intercept as well. So 3 is done. Now 4. The y-intercept. How do I find the y-intercept? Right, so I have to find f of 0, which is? Perfect. And the ordered pair is? Perfect. 5 and 6 are just words, but are important words because one is used to keep the graph in shape, and the other one is really used to give us the range. So that's why these are so important. So what is the axis of symmetry? Very good. X equals -5, axis of symmetry. Since this parabola has a minimum, what is its minimum value? Yes. Very good. 0. Can anyone give us the range? Right. So we know how the graph looks like. I'm going to fake 25. So 1, 2, 3, 4, 5. Here's the axis of symmetry. And with your permission, I'm going to say that this is 25. It's not. So I'm going to graph it. Now, since I don't have a point on the other side, I'm going to say this has to equal this. So I'm going to create a point here. As long as it has 5, so this point and this point are 5 units away from the axis of symmetry. So this has to be 5 units, and this has to be 5 units. Okay? So this is the graph of f of x equals x squared plus 10x plus 25. Why? Because I know that this is x plus 5 squared. So it's x squared shifted to the left 5. Okay, and the last one, it's this. Any questions on this problem? So f of x equals -5x squared plus 5. We want to graph it. First step is the shape. So a equals -5. Yes. Which is less than 0. So the quadratic function has a maximum. Agreed? Yes? Okay. Number 2, the vertex. Negative b over 2a. But how much is b? Careful. b is 0 divided by 2a, which is -10. So how much is this? Right. 0, comma 5. Very good. Number 3. The parabola has, yes, Becky? I have to plug in 0. That's what we always do. We plug in this to find the y, right? Good. So now the parabola has a maximum. Its maximum value is 5. Will it cross the x-axis? Yes, of course. So I will have to find the x-intercept. Otherwise, I don't want to waste my time. How do I find the x-intercept? Yes. So I have -5x squared plus 5 equals 0. It's a quadratic equation, but it's binomial, descending order. Yes. Greatest common factor. Yes. And it's one that I can, and I'm allowed, and I should get rid of. What do I want to get rid of? Of course. So this is x squared minus 1 equals 0, which is way more human. I have several ways here. I can factor and get the solutions, or I can move one to the other side and apply what to both sides? Right. Well, it's easier to say x minus 1, x plus 1, and I get two options, 1 and negative 1. So then what are the x-intercepts then? Very good. 4. Y-intercept. Is there a need? No, I already have it. It's 0, 5. It's right here. It's the vertex itself. That is the y-intercept as well. Y-intercept is 0, 5. Now 5 and 6 are just words. What will you say is the axis of symmetry of this problem? Yes, x equals 0, indeed. Axis of symmetry. Since it has a maximum, the maximum value will be, max is 5. Can anyone give us the range? It has a maximum, and the maximum is 5. To 5. Very good. So let's graph it. I start with the vertex, which is 0, 5. Not 4, sorry. 5. Then the x-intercepts, negative 1 and 1. There is no point in drawing the axis of symmetry because it's just the y-axis. And that's it. So this is f of x, negative 5x squared plus 5. Any questions?